Okay, move this up for more room here. When we do that, that becomes a 1, leaving us cosine A. And this will be equal to, actually it's going to be like a negative 0.25696 and blow on, blah, 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 blah. Just keeps on going forever. Okay, now, when we put this in our calculator, and I'll do that, let's put that in there. We're going to take 332 divided by a negative 1292. We get this number, this negative 2.25696594443, and so on and so forth. We know, according to our practices from before, cosine of an angle equal to x, some value, actually tells us that the measure of the angle A is actually cosine inverse of x, or whatever this number is. Right? We talked about kind of the concept if you were dividing cosine out of that angle. And then cosine, 1 over cosine is like cosine inverse, right? So that's cosine inverse of this times that. So negative 0.25696, so on and so forth. So if I did second cosine on my calculator, so cosine inverse, and I arrowed up to grab that number and put enter, hit enter, I'm going to end up with 104.8 or 105 degrees. And that is your answer D. That's the largest degree that we have there. So just using the law of cosine, we can find that measurement. Okay, on to the next page, number 12. Number 12. This is a little bit tricky. This is naming the similar triangles, and we had a little trouble with this on our quiz because we would get things out of order. Okay, when there's an angle, that you're dealing with, you need to keep that angle in the right order every time if possible. And then if you're talking about right angles, you obviously want to keep corresponding sizes of angles with corresponding sizes of angles of the two triangles that are similar. So in the first one, it does put the right angle in the same spot every time. So Z, we're going to go Y, Z, X. So this is our right angle. That's our right angle in this triangle. And that's our right angle in that triangle. But if you notice, this one starts with Y, Z, X. The next one is W, Y, Z. Well, we really need to start with Y because we started with Y on that one. And Y, there's only one version of that angle in this scenario. So because these are not in the same order, this is not going to be the answer. These here, if you go through these, they're mixed up. The order's wrong. They put the right angle in the middle. They put the right angle at the end. But if you look at C, C should be your answer on this one because they put Z, Y, X. Z, Y, X. There's our right angle at the end. W, Y, Z. W, Y, Z. Right angle at the end in this large triangle. And W, Z, X. They start with W. They start with W. And they keep the right angle last in every naming of the triangles. And so C would be your answer because it puts everything or keeps everything in order. Okay? Number 13 and 14, pretty simple. Again, these are not hard at all. If we use special right triangles and we had sine of 45, if you'll remember, a 45, 45, 90 triangle, if you had 1 on the sides, then the square root of 2 was the hypotenuse. So if I took sine of either one of these, it's opposite over the hypotenuse, right? Sine of 45 is opposite over hypotenuse. Now, we don't like the radical in the bottom, so we multiply it times square root of 2, multiply the top times the square root of 2. So that's the square root of 2 on top, and the square root of 2 times the square root of 2 on the bottom is 2. So that would be C. Now the other thing you could do here is you could say, well, okay, I don't remember what the special right triangle is on this one, but what is the sine of 45? Oh, sine of 45 is 0.707106, blah, 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 blah. Okay, which answer down here is the same thing? Oh, well, I'll try square root of 2. Let's see here, square root of 2. Nope, that's not it. That's not the answer I'm looking for. I can try square root of 3 over 2. That's still not it. I can try square root of 2. Oh, let's take that divided by 2. Oh, looky there, square root of 2 and then we divide it by 2, that gives me the same answer. Voila, you've got it. So you could find it by using the calculator, or you could find it by knowing the special right triangles. Same thing on number 14. Sine of 30, we're going to have our 30, 60, 90 triangle. And the sine of the 30 angle, if this was 1, that would be 2. That would be 1 times the square root of 3. And so the sine of 30 is going to be 1 over 2. That's my answer. If I put sine of 30 inside here, thank you for that yawn. I'm so glad you're staying awake with us, Abby Mullen. Not to call you out on the video, for that everybody's going to be watching. But anyway, sine of 30 is half, 0.5. Well, which answer is half? Oh, that one. Okay, let's move on to the next questions. 15. Oh, sayonara. We're not going to work on you. Or 16. But 17 we will work on. So we're skipping 15 to 16, going to 17. Which statements are true about the triangle FGH? All right, now here's what we're reinforcing. Do you know what the cosine of H is? The cosine of H is adjacent over hypotenuse. It's 36 over 39. The tangent of G is 36 over 15. The cosine of G is 15 over 39. And the sine of G is 36 over 39. Now, you put those fractions in your calculator and see if they equal that decimal. And you'll find out real quick that one does not match. That one does. This one does not match, but that one does. Okay, again, let me just show you. If you put in 36 divided by 15, what do you get? 2.4. So the tangent of G should be 2.4, and it is. If we put those side lengths over each other, we get 2.4. All right? And on this one, sine of, 36 divided by 39 should be 0.9237 or 07, and sine G is equal to that decimal form, and so that is the correct answer. Simple enough. Let's go to the last page. We're not doing 18. Exit off again. Number 19, which expressions are equal to 1? Another gimme question on this test. All right, you just put in the calculator tangent 60 times tangent 30, and you're going to find out it's equal to 1. You're going to put in sine 30 divided by cosine 60 in your calculator. It's equal to 1. You're going to put in cosine 45 divided by sine 45. That's also equal to 1. But when you put that one in there, it does not equal 1. Okay, it's just calculator work. I'm going to put calc beside it. Okay, that's an easy one. Last but not least, number 20. Number 20, I like this problem. We had a couple of these in here. Probably should have left 2 of them in here, right? You're going to say, oh, yeah, Coach, we need another one of those because that's an easy one. But number 20, we're trying to find the value of m to n, or this x value. Okay? That's what we're trying to find, x value. What trigonometric ratios can we use in this triangle to find x? We have this angle right there. That's all, the only angle we have right now. But look here. Doesn't matter what this angle is. We have N and L. So I could say, okay, watch this. I know tangent of 60 or tangent of N is going to be this over that, right? So that involves x. So we can use tangent of N, and it would be 5 times square root of 3 over x. That one would work, right? I know that cosine of N is x over 10. It involves the x side, right? So cosine of N is going to be x over 10. That would give me the x answer. I know sine of L. Sine of L would be opposite over hypotenuse. That'd also be x over 10. Okay? What other ones do I have? Tangent of L. Tangent of L would be x over 5 times the square root of 3. Now the other ones don't help me, right? Sine of n doesn't give me x. Cosine of L doesn't give me x. But those four do. Now, do any of these match our answers? Well, sine of n. Does sine of n help us? No. Cosine of n, does that help us? Yes, and it's x over 10. That's correct. Does tangent L help us? Tangent L is x over 5 times square root of 3. That does work for us. And tangent n, yeah, tangent n helps us. 5 times square root of 3 over x doesn't match. So that's not our answer. Okay? See how we're doing? We're just matching up the relationships with those problems. All right, that should conclude your test review. It is tomorrow. I will send out a remind for everybody. So rather quickly, I will put this on here for the ones that are in class right now. It probably won't help many people that are out there, but we will put it up there for my geometry kids. Do good, study hard. We'll see you guys tomorrow.